Okay, so I'm going to zoom in on this. I hope that's easily visible. So what we have here is 21 plus 21 plus 37 plus 19. And the idea is you want to add all four of the numbers. Now, let's do a quick bit of review because we haven't done this in a little bit. It's been a week. So what you're normally taught to do, what a student is normally told to do, is to take all of the ones, that's this one, right, this column right here, and to add all of the ones up, okay? And there are lots of ways you can do that. The way I do it is I take the 1 and the 9, and that makes 10. That helps me because then I know that what's left, this 7 and this 1, make 8. So it's beside the point, but the actual number that I'm making is 18, right? Or you could count it up another way. There are lots of different ways that you can order this. Remember those associative and commutative properties that we talked about last time. Addition can be done in whatever order you want, frontwards, backwards, whatever. And the way I do that is I take advantage of the fact that tens are easy to deal with, which is why I choose to make tens. And in this case, it makes perfect sense because as a kid, what I would have been taught is, okay, so I've got my 18, and then I carry the 1, and then the 8 goes here. And it seems obvious now because we've spent 3 weeks really laying a solid foundation for where carrying the 1 comes from. But when I was a kid, I didn't really understand that what I was doing was taking a pile of 10 ones and compressing them into one 10 grid, essentially, and moving that over into the tens side. I didn't quite get that. I didn't realize that the 8 was just the remainder after we pulled out as many tens as we could. And then you take all the tens and you add them all up. In this case, I'll just count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 tens and 8 ones for a total of 98. Assuming that I didn't mess that up somewhere, which I might have. Not this time. Okay, 28 plus 11 plus 34 plus 17. So now I'm going to do this a slightly different way. Okay, when I see 28 plus 11, well, I can do that without any carrying, right? 28 plus 11. Hold on. I'm still erasing. Got it. 28 plus 11, that's 39. That's not so bad. Then I add 34. Let's see, 39 and 34. So 9 and 4 is 13. Carry the 1, right? Make that one group of 10. We've got 30, 60, and that one group of 10, we end up with 73. And then we're adding 17. 3 and 7 is 10 with 0 left over. We carry the 1, we carry the one group of 10, and we have 73 plus 17, or we have 70 and 10 is 90. Now, my notation here isn't very good because it's been a while since I've had to actually write out my process for an addition problem like this. But you shouldn't be asking your students necessarily to write out every step. If they can, then great. But if they can explain their steps, that's just as good, if not better. Don't sweat the writing down every single step this early on. That comes a little bit later. So I got 90 here, which again could very well be wrong, but I'm going to find out. Okay. So far, I haven't managed to make a big mistake yet that caused me to get a problem wrong. It will happen, and when it happens, I'm actually going to be glad. I'm not going to do it on purpose, but I'm going to be very, very glad. This is an easy one because 33, 22, and 11 very neatly make 66. And 66 and 14, 6 and 4 is 10. Carry the one group of 10, we end up with 80. You'll notice my notation is so bad I don't even put the plus in there. There we go. So I hope that you can see that getting the 66 was just a shortcut of knowing that 3 plus 2 plus 1 was 6, both in the ones and the tens place. Let's see, 42 plus 31, that is 73, plus 12 is 85, plus 14 is 99. I hope you could follow that, but if you couldn't, when you see this VOD, go ahead and pause the video and go back and follow that if you can. That is generally the way I do this. Now, you don't have to do it this way. The very first thing that I did, the very first technique that I used was instead to line up all of the ones and combine them, filter out any groups of 10 that you can, and then combine all the tens together. And in fact, let's go ahead and do this that way as well, just to make sure that I'm covering all my bases. Although I imagine we're going to have plenty more time to do more examples. So I could put this as 42, 31, 12, 14. I'll remember to put my plus. So I have 4, 5, 6, 7, 8, 9. I just counted that up. No tens to carry. 4, 5, 6, 7, 8, 9, or 90. So we had 9 ones and 9 sets of 10, so our answer is 99. And that's that. Break apart two-digit addition problems. So I have a feeling that this is going to reinforce the thing that I was just talking about before. Which of the following is equal to 89 plus 8? So again, it's not asking for an answer. It's asking for a process. And the process is 80 plus 9 plus 8, right? Because 89 is equal to 80 plus 9, and then we're adding another 8. So that's kind of the first step when we are doing this multi-digit addition. We break it apart into the ones place and the tens place. We add the ones places up, or the ones up, etc., etc. 63 plus 11, well, let's see. 63 is 6 tens and 3 ones, so 6 tens and 3 ones. C has 6, 10, and 3 ones. 11 is 1, 10, and 1, 1, so I think it is C. But let's double check the other answers just in case. 6 tens plus 3 tens is 90, plus 2 ones is 2. So A would be 92, so that's wrong. And then for B, it's all ones, so we get 6, 7, 8, 9, 10, 11 ones, oops, all ones. So, I believe C is the correct answer here. Joel isn't sure how to add 65 plus 17. Help Joel by choosing an addition problem that is the same as 65 plus 17. So again, if you are able in your head right now to crank out, I believe the answer is 82. Okay, I'm pretty sure that's the answer. I did that in my head. Very good if you are capable of doing that. But it's also important, especially as an educator. And remember, these videos are not aimed towards first graders. These videos are aimed towards those older folks, young adults and adults who are possibly helping to educate these young children. And you have to think about the way they think about things. It's going to be a very rare 6 or 7-year-old who's capable of doing 65 plus 17 equals 82 in their head. In fact, it's the rare high schooler that can do it very, very quickly in their head. So being able to take a big, difficult problem and break it up into several smaller, easier to digest, sub-problems is not only going to help them in math, but that's a life skill that comes up all over the place. It comes up literally as I'm setting up for this stream and making these videos. Anyway, rant over. 65 plus 17 is 60 plus 10 plus 5 plus 7, right? 65 and 10 and 7 is 17. What do we get when we break apart 35 plus 16? Well, we get 3 tens and 1 10 and 5 ones and 6 ones. The answer is B. The way we break up these problems and manipulate them is the same thing that we're going to end up doing to manipulate variables and equations later on down the line. That's why it's so important that that students are able to vocalize how they make these addition problems work. How do they actually do the addition rather than just reaching for the calculator? Calculators are fine. I love calculators. I have a calculator like in my phone that I can ask any question and it's fantastic. But remember, if you don't understand what the calculator is doing, you have no way of validating the answer for yourself, and that's important.